Subject name Operating Systems. Class 2nd year 4th semester. Topic Interrupt Handling and System Calls in Unit 1. Operating system is system software that manages computer hardware and software resources and provides common services for computer programs, which is acts as the intermediate between computer user and the computer hardware. Interrupt handling. Interrupts are generally called signals, which are generated by the software or hardware when a particular event or process requires immediate attention. So, the signal informs the processor about the high priority and urgent information demand causing an interruption in the current working process. System calls, which is provide an interface to the services made available by an operating system. The system call is a way for programs to interact with the operating system. Interrupt handling and system calls. So this is a system calls which is using the input-output operation, which is loads the appropriate register in the device controller. So what is the action it will take means read the character from the keyboard. The device controller transfers the data from one device to the another device, and it transfers the data. Once it is completed, the device controller informs the device that it has finished its operation. Thus, the accomplished. There are three ways to find interrupt handling and system calls, that is overview, implementation and operating system operation. The first one is the overview. The interrupts are a key part of how operating system and hardware interacts. When the CPU is interrupted, it stops when it's doing and immediately transfers its execution to a fixed location. See, what is a fixed location contains? It contains the starting address where the service routine for the interrupt is located. Once the service routine executes on completion, the CPU resumes the interrupted computation. Implementation. The basic interrupt mechanism works as follows. The CPU hardware has a wire called the interrupt request line that the CPU senses after executing every instruction. It then starts execution at the address associated with that index. While the interrupt handling saves any states need to change, and it determines the cause. It performs the necessity processing and restores the state and executes the return from interrupt instruction to return the CPU to its original state. Let us see the operating system operations. Modern operating systems are interrupt driven, so events are almost always signaled by the occurrence of the interrupt or a trap. See, trap or execution is a software generated interrupt caused either by an error, that is division by error or invalid memory access, or a specific request from the user program. In the operating system operations, for each type of interrupt, separate segments of code in the operating system determine what action should be taken. Then, the interrupt service routine is provided to deal with the interrupt. While sharing, many processes could be adversely affected by a bug in one program. Suppose any process gets stuck in an infinite loop. This loop could prevent the correct operation of many other processes. Many subtle errors can occur in a multi-programming system where one erroneous program might modify another program, the data of another program, or any operating system itself. Operating system operations will do two types of operations. First one is a dual mode and multi-mode operation. The second one is a timer. Here, dual mode and multi-mode operation. In this dual mode and multi-mode operation, we need two separate modes of operation. The first one is a user mode and the second is a kernel mode. A bit called a mode bit, it is added to the hardware of the computer To indicate the current mode, kernel is termed as 0 or user is termed as 1. In dual mode and multi-mode operation, when the computer system is executing on behalf of the user application, the system is in user mode. However, when a user application requires a service from the operating system, the system must transition from user to kernel mode to fulfill the request. The next one is a timer. At the system boot time, we must ensure that the operating system maintains control over the CPU. We cannot allow a user's program to get stuck in an infinite loop or to fail to call system services and never return control to the operating system. To accomplish the time management, we can use a timer. The timer can be set to interrupt the computer after the specified period. The period may be fixed or variable. For example, from 1 millisecond to 1 second. Thank you.